Let's talk about firmware. Check this out. Before your operating system even wakes up, before your Windows and or your Linux blinks into existence, there is a hidden commander calling all the shots. It's not your CPU, it's not your operating system, it's the firmware, the invisible boss running the show from the shadows. Sounds like sci fi, but it's not. Let's crack open the black box of your computer's secret mind. What is firmware? Okay, think of firmware as like a general that is in charge of an army. Your hardware, it gives your CPU, your RAM, and the GPU their marching orders. The moment you hit power, it's not as flexible as software, but it is not as dumb as hardware either. It is a perfect hybrid, fast, fixed, and focused. Without it, your PC wouldn't even know how to turn on. BIOS and UEFI. What does BIOS stand for? Basic Input Output System. That's correct. What does UEFI stand for? Unified Extensive Firmware Interface. And the differences between BIOS and UEFI would be old school and new school. BIOS, that's like an ancient wizard from the 80s typing in command spells one line at a time. And then the UEFI would be the evolved descendant, that is slick visual, 64-bit, and built for the modern tech. BIOS lived in the age of floppies, and the UEFI rules the age of the NVMe drives. What does NVMe stand for? Non-volatile memory drive. That means non-volatile means it stays saved. The memory is saved even when the power is off. And then what does volatile memory? Yes, it gets erased when the power is off. What's an example of volatile memory? RAM, random access memory. Yeah, so the UEFI rules in the age of NVMe drives and secure booting. One boot is like a cassette deck, and the other is like a Tesla. Welcome to the upgrade. So, your firmware needs a memory, the firmware's memory needs a keeper. And that's where the CMOS comes in. What is a CMOS? What does CMOS even stand for? It stands for complementary metal oxide semiconductor. That's where the CMOS comes in. It's a tiny memory chip that stores the system settings, the time, the boot order, and more. But here's the trick. It needs power even when your PC's off. It needs power. Enter, that's where the coin-sized CMOS battery enters. Without it, your system forgets everything, like a robot with amnesia. Okay, so inside the system setup of the UEFI settings, welcome to the cockpit, the system setup screen. This is where tech and exam questions love to hang out. You'll see tabs like main, boot, advanced security, change time and the password, toggle the virtualization and enable the security boot, or rearrange the boot order like a digital Tetris. Want to boot your USB? Right here. You need a PXE, or a hardware virtualization, which is also here. Wait, what does PXE stand for? That's right, pre-boot execution environment. Pre-boot execution environment. Yeah, and then the pro tip here is you're going to need to be able to memorize the access keys, such as delete F2 or delete F10. They will save you in the heat of an exam. This is your PC's control tower. Yeah, so we go to the firmware security superpowers. Firmware isn't just the boss, it is also the bouncer. let's talk about the secure boot. It scans every driver and operating system loader, and if it is not signed and trusted, it is not getting in. Then there is the TPM. The TPM stands for Trusted Platform Module, and you can think of it as the PC's vault for encryption keys and BitLocker protection. You set the admin password to the block snoops and you disable the USB boot to stop the malware installers. Because the real pros protect their firmware first, remember this: secure boot is equal to a malware shield. It's like an antivirus for your motherboard. Okay, now we talk about post, the PC's morning routine. And every time you hit the PC, they hit the power, your PC doesn't just wake up, it checks itself out. That's the post, the power on self-test. You beep once, it's all clear. And you beep multiple times, it's basically Morse code for something is wrong. And then one long or two short, that's probably something wrong with the video card issue. And then there's rapid beeps. That means your RAM is freaking out. And then if there's no beeps, there's probably a power or a motherboard problem. And if you ever want to sound like a real tech guy, you can say, I'll grab a postcard to diagnose that. It sounds futuristic, but it's a smart troubleshooting method. And then we talk about the boot process. There is the legacy versus the UEFI. Okay, the legacy is you walk in an old path, which would be the post, the CMOS, the boot order, the master boot record, and finally the Windows Limbus to live. And then there is the UEFI. That is like the most modern train ever. It goes straight to post, to the boot manager, launching your operating system loader in seconds. And then there's the PXE. What does PXE stand for? That's right, Pre-Boot Execution Environment, PXE boot, the network-based ninja move. Your PC downloads its operating system straight from the server, and no USB, no disk, and just pure digital sorcery. Just remember, PXE is equal to the network boot. Just don't miss it. So when it comes to when it comes to fixing and resetting the firmware settings, when your BIOS starts acting haunted, weird settings, lost passwords, boot fails, you've got one move: reset your CMOS. What does CMOS stand for? Complementary metal oxide semiconductor. Most of the time, you can just load defaults. But if you are locked out or the settings are truly broken, then you have to use the jumper on the board, or just pull the CMOS battery out for a few minutes and then boom, a clean slate. Some high-end boards even have a dedicated clear CMOS button. This trick usually fixes 90% of the firmware freakouts. And it's important to know that reset CMOS is equal. It actually recovers you from bad configurations or forgotten passwords. Okay, and then when it comes to updating your firmware or flushing your BIOS or UEFI, flushing the firmware is like brain surgery, necessary sometimes, but very risky. Why do people do it? Okay, maybe if you have a new CPU or a new RAM support, or you need to fix a few bugs or better the security. How to do it? Okay, you use vendor tools or a USB flash updates from your motherboard manufacturer. But here's the warning label: if the flash fails or the power cuts out, congratulations, you just bricked your board. So don't flush unless you have to. This isn't a fashion update, it's like a firmware evolution. Okay, now we talk about firmware exam nuggets. Your final upload. This is your firmware cheat sheet. Your firmware is equal to your pre, operating system command center, and then all of this is stored in a flash ROM. Survives power off. What does ROM stand for? Read only memory. Access setup with delete or F2. Secure boot, it blocks unsigned bootloaders. TBM, what that does is it is the encryption vault. What does TBM stand for? Trusted Platform Module. And then PXE, that would be your network boot. Wait, what does PXE stand for? It stands for your pre-boot execution environment. And then you have your CMOS battery. If it's dead, the clock resets. And then there's the one shot beep, means the power on self-test is okay. Just remember that the firmware isn't software, but it's also not hardware. It's like the boss that is whispering orders to the hardware before Windows ever loads. Trust me, this is like an invisible layer. This is the future system control and the key to acing your exams.